Right, so we're here at Linaro Connect. So who are you?
My name is Tom Gall, and I'm the tech lead of the graphics working group.
So, graphics in ARM devices, right?
That's correct. And it's a wide collection of things that we could take on. So there's activity within the kernel layer, and largely this is in the nature of panel drivers and kernel device drivers, and then we go up into user space where we're looking to go and provide optimizations for certain libraries which are important on the graphics stack, and that can be anything from audio-visual libraries that would be used in multimedia type applications to, in some cases, audio. And a lot of the times what we do is we optimize using Neon. So one of the things in particular for this Connect, which has been fairly exciting, is we're starting to look at what we might be able to do with GPGPUs, which is general purpose computing on a GPU device. And for the ARM universe, that's something entirely new.
So does that mean faster, lower power?
It does mean faster and lower power. It's very interesting because typical workloads that have been thrown at SIMD, i.e., going off and using Neon instructions, it turns out if you take those same kinds of activities like encoding and decoding of video and put them onto a GPU and do it on the floating point, capabilities of the GPU, it's even more power efficient and even faster in that type of environment. But it's a little more challenging because in the case of the GPUs, the GPU manufacturers, such as the Molly's and the Adrenos and PowerVR and all that, they don't make the drivers available to talk to the GPU itself. You have to go through a binary device driver to do that. So we've got a challenge to take advantage of a technology called OpenCL to take advantage of the power that's really there.
So, OpenCL, OpenGLES3,
yeah,
Mali T604, Mali, the next Malis. There's lots of work, right?
There is a lot of work to be done, but it's a very exciting time. We've got OpenGLES3, which just came out as a standard this last summer, so it was ratified, and we have an implementation of that standard now within Mesa. So that came out in Mesa 9.1. Mesa 9.1 was even certified as being GLES3 compliant just in February. So it's pretty incredible times.
It's fun?
It's very fun.
So can you describe a little bit what you do day by day?
Well, day by day as the team lead, I'm looking over what my team is concentrated on, which is primarily something called CDF, which is the Common Display Framework. It's something that we're going out and we're working with the community, and we're trying to come up with a kind of a KMS-like infrastructure within the kernel so that it's easy to write panel drivers and controllers, and so not everybody, you go back in history on ARM, they would go and create all their own little drivers. There was no sharing going on, and thus if you wanted to create a implementation with a panel, you had a lot of code to write. Well, with CDF, you're going to get to a point where you can write a panel driver and 800 lines of code, and that is pretty cool. It makes things go a lot faster as far as development is concerned. So, as the team lead, I've got to watch out for those things. I got to still, push things along in the community. Laurent Prashard, he's been just awesome at, getting the draft standards. And then in my team, we're taking those draft standards, we're implementing them as prototypes, and pushing out the reference patches so that other people can potentially prototype it on their boards with their own panels, and make what will ultimately be the final design all the more better. Another thing that we've started to get really interested in, but we're still kind of trying to understand how we can most be effective with, and that is the hardware composer on Android. So there's some work there around Grolic and between Surface Flinger and the hardware composer to kind of do efficient composition of graphics, and kind of how to implement that right. But when we do that, we want to make sure that we come up with something that's going to be meaningful to the Android community, and of course that Google would ultimately go and pick up.
So you had some presentations here. What kind of things did you talk about?
So our presentations were on the CDF framework. We talked about what was going on in the GLES community and how we could be involved with that and kind of continue to push the state of the art. We had some initial sessions on GPGPU and how we could take advantage of the horsepower that's on a GPU on ARM hardware for a variety of workloads, for everything that was graphical oriented to even boring enterprise stuff if enterprise is boring to you, but accelerating a database by 20x, as some people have done. Even though it's SQLite, SQLite is in the heart of everybody's Android phone. So it's actually fairly cool, and we think we can do some things in that space. Another, some other things that we're thinking about, but we're not quite sure yet as far as what we're going to go and do is, we still see some need to optimize WebKit a little bit. WebGL is an area that's pretty fertile. It's fairly early in its life cycle, so it has some needs for optimizations, and how we're going to do that and pull that off, we're not quite sure. Another thing that we're thinking about is in the audio side of things, there's an old library that's always been in use called OpenAL, and so this is for doing 3D audio, and a lot of game engines still use it today, but it's straight C. Nobody's ever gone and taken advantage of Neon, which when you're doing audio things, it's a no-brainer. You get some good wins, and what it can do then is take and shrink the amount of CPU cycles which are required to do audio, which can it could translate into a couple more frames per second.
So that sounds awesome. I see the ARM-powered Chromebook as the coolest device in the world.
Yeah.
So fantastic, so awesome. There's a Mali T64 in there.
That's right.
It's Chrome OS. What could they do to maybe have more hardware acceleration?
At this point, at least, when we view the Mali as, it's a really exciting reference board that the average person, average developer can go pick up for a couple $100 and basically cheaply have a really good ARM A15 based system with a really good graphics chip on it. The Mali team does have a device driver for it. It also has an OpenCL library that's for it. So the seed is planted, the hardware is available. You can easily pick it up, and I think it really enables people to do some really great things, including our own team. We've been picking up Chromebooks, and we're really excited with the possibilities.
But can you describe a little bit what the opportunities are? Like, could we, let's say, have longer battery life on the Chromebook, the one that's already out? If they use it better somehow?
I think there's probably some things that can be achieved there. The power management guys are really the ones to talk about that. I think from a graphics perspective, what we might be able to do by offloading activity that's on core onto the GPU could achieve some of that longer battery life. Now is that a couple percent, or is that more than that, or even less than that? That really remains to be seen.
All right. So you're looking forward to what's going to happen next month?
I very much am excited by what we've got planned in the next months, and getting down to write some code. And ultimately for us, the next big event is Dublin, and hopefully we can get to report on some of the results.
Are you satisfied with your team?
Very much so.
Yeah?
Yeah. I've got a great bunch of guys.
How many guys are there?
We just have 6. So the graphics team is kind of fairly small. 4 of the guys are working on CDF. And so we've got Sumit Simawal, who's he's been kind of the champion of a DMA buff, as well as working with a whole bunch of other people on that too. But he's kind of our DMA buff guy. It's great working with a very talented set of engineers.
You can need help? More people?
More is always better.
But is it harder to organize when there's more people, or?
Oh, it's always a challenge when you have a larger team. But on the other hand, that's a really good challenge to have. I think, when you have more engineers, then you can get into a larger set of problems, and in many cases, get those things solved a little bit sooner. We've got a nice list of things that we would love to do, but we can't do just because we don't have the engineers to get engaged in working on it.
Cool. So thanks. Looking forward to GPU compute devices in the bucket, in the bag, everywhere.
Me too.